Hello everyone and welcome to DeepNets. In this video, we are going to talk about artificial neural networks or so-called ANNs. More specifically about Perceptron. An artificial neural network is a machine learning model inspired by the networks of biological neurons found in our brains. However, over the course of time, these ANNs have gradually become quite different from their biological cousins. ANNs are the very core of deep learning. They are versatile, scalable, and powerful, which makes them perfect to tackle large and highly complex machine learning tasks, such as classification of billions of images, for example, Google Images, or empowering speech recognition like Apple's Siri, and recommending videos to watch like on YouTube. They can even beat humans in their own game, like AlphaGo and chess. But we will talk about this in a different video, because this belongs to a different part of deep learning, called as reinforcement learning. Let's shift our attention towards Perceptron. The Perceptron is one of the most simplest artificial neural network developed by Frank Rosenblatt. It is based on a slightly different artificial neuron called the threshold logic unit, also called the linear threshold unit. In short, we will call it as TLU. Let's explore each component of a TLU individually. TLU starts with the input layer, consisting of the inputs you feed to the network. The input layer exactly works like the function f of x equal to x. That means the sole purpose of the input layer is to output its inputs. Each input has a weight associated with it. This is the base of deep learning or even machine learning. Then the TLU performs a weighted sum of its inputs and pass it to a step activation function. Finally, we get our output. Now, the step activation function is generally a sign activation function or a heaviside activation function. I have made a different video on activation functions in which I have completely explained about activation functions and their uses. You can check that out for having a clear understanding of activation functions. A perceptron simply composed of a single layer of TLUs, with each layer connected to all the inputs. When the neurons in a layer are connected to every neuron in the previous layer, the layer is called a fully connected layer, or simply call it a dense layer. Once the inputs are fed to these TLUs, they perform the respective calculation that we just looked at and return us the final outputs. But the question comes, what is the equation for computing the outputs of a fully connected layer? Well, mathematically we can describe it as h of x, which represents our final output values. It all starts with a matrix multiplication between the feature matrix and the weight matrix, containing your features and the weights associated to those features. This step is completed by the addition of a bias term. The bias term is added to make sure that the neuron does not die. This problem is called the dying neuron problem. I have addressed this problem in the video of activation functions. I recommend you to check it out. It's really awesome. This problem can easily be solved by choosing the right activation function. Hence, in last, the activation function is applied to the outputs. But what is the idea behind learning, or how does all this happens? Well, the idea behind learning is cells that fire together get wired together. That is, the connection weights become larger if two connected neurons fire simultaneously. This is known as the Hebb's rule, also called the Hebbian learning. The training of perceptron is based on gradient descent. The decision boundary of each perceptron is linear, so they are incapable of learning complex patterns. However, if the training instances are linearly separable, perceptron can be a good solution. That is called as the perceptron convergence theorem. It turns out that many problems of perceptron can easily be eliminated by stacking multiple perceptrons together. The resulting artificial neural network is called the multi-layer perceptron. That's all for this video. In the next video, we will talk about multi-layer perceptrons. Links to the topics that I have told but are incomplete, like the activation functions and gradient descent, are available in the description. You can check that out. Otherwise, I recommend you to check out my playlist so that you can gain access to all my videos in a single click. That's one connection with Deep Nets. See you next time.